Good afternoon, guys. Good afternoon, and welcome to fresh week of our classes. So today we are discussing about fluid dynamics, second topic of Unit 2. Second topic of Unit 2. So in the last class, we have discussed about the problems related to one-dimensional, two-dimensional, three-dimensional, and also fluid net analysis, and the flow analysis. And also we have seen the velocity and the acceleration concepts, also, right? So here now we'll see the fluid which are in dynamic motion, right? In the last previous classes we have seen about the fluid kinematics, where the one element is not considered, that is a control pressure element is not considered, right? Now we are the stream and velocity potential functions is also completed, the flow net analysis also completed. Now we are dealing with the fluid dynamics, right? So in the kinematics we have studied about the forces which are not considering, we have studied only about the time, whereas here we are considering the forces also, right? In this fluid dynamics, it is the study of motion and fluids in motion, where the pressure forces are considered, right? So if I brief the earlier definitions, the fluid mechanics means the science that deals with the behavior of the fluids which are at rest or in motion. So when the fluids which are at rest, we are calling them as a fluid statics. When the fluid which are in dynamics, we are calling them as a dynamics. And the interaction of fluids with the solids of fluids at the boundaries Now, what is the fluid kinematics? The study of fluids in a motion. Where pressure forces are not considered. Pressure forces are not considered, we are calling them as a fluid kinematics. Wherever the pressure forces are considered, or we are calling them as a fluid dynamics. Okay, now next, the fluid in a motion is subjected to several forces. So generally, when a fluid is flowing in a pipe or open canal or a river or a stream or any place, it is subjected to several forces, which results in the variation of the acceleration. So the change takes place at that acceleration. The change takes place at the acceleration, and the energy is involved in the flow of the fluid. So whenever the motion of fluid is subjected to several forces, so there will be the variation in the acceleration as well as the energy. The study of the forces and energies that are involved in the fluid flow is known as dynamics of fluid flow. So what it is saying, the study of various acceleration is nothing but the force, right? The study of forces and the energies involved in the fluid flow is nothing but dynamics of fluid flow. Now we'll see some of the definitions. The various forces or accelerations acting on the fluid mass can be classified as three types. Okay, so here the forces, we are calling them the acceleration as a forces, right? The forces that are involved in the fluid flow is known as dynamics of fluid flow. Now the various forces acting on the fluid mass is classified as, first one, body or volume forces, second one, surface forces, third one, line forces. So what we are calling them as, first one is a volumetric forces or body forces, second one is a surface force, third one is a line forces. We'll see each of them in detail. Now we'll see the first one, the body forces. What is the meaning of body forces? The body forces are the forces which are proportional to the volume of the body, See the examples. If you see the examples of those, the weight, the centrifugal force, the magnetic force, and electromotive force. The body forces are the forces which are proportional. These are the forces which are proportional to the volume of the body. So which are proportional to the volume of the body, we are considering them as a body forces. Example, the weight, the centrifugal force, the magnitude, and the electromotive force. Okay, na? Next. The second one is a surface forces. So boundary means, for example, if this is a container, so whenever the water, for example, if this is a pipe where the water is flowing in the pipe, where the water is flowing. So whenever it is flowing, this one is a boundary, and that one is a boundary. So the body forces acting which are proportional to the volume of the body. So what is the volume of the body? So based upon that, we'll consider the body forces. The second one is surface forces. The surface forces are the forces which are proportional to the surface area. The surface area, which may include the pressure force, shear force, tangential force, force of compressibility, and force due to the turbulence. Forces due to the turbulence is nothing but the surface forces. Next, the line forces. Next one is the third one is the line. The line forces are the forces which are proportional to the length. So for example, if having the pipe length of 2 meters, it is the forces that are acting proportional to the lengthwise. Example, surface tension. What is the property which you have discussed in the unit 1? The surface tension properties, right? Right. Next one. The dynamics of fluid flow is governed by Newton's second law of motion. So the generally dynamics of flow, fluid dynamics వచ్చేసి దేని మీద ఆధారపడి ఉంటుంది? These are governed majorly by Newton's second law of motion, which states that the resultant force of any fluid element, is this new person? Okay, 3%. Okay. The fluid on any further element must be equal to the product of the mass. And acceleration. So it states that the resultant force R is equal to the mass of the product and acceleration of the element, and the acceleration vector as the direction of the resultant vector. The fluid is assumed to have the incompressible and non-viscous flow. Then what is F? F is equals to mass into acceleration. These are the resultant force is equal to the mass and acceleration. Now where F is equal to represent as a resultant external force. F is representing as resultant external force acting on the fluid. And the element M is a mass and A is a acceleration. Both the acceleration and the resultant external force must be along same line of action. The acceleration and the resultant. The acceleration and the external force must be along the same line of action. The force and the acceleration vectors can be resolved along the 3 references directions such as x-axis, y-axis, and z-axis. And the corresponding equations may be expressed as f of x is equals to mass into acceleration at x direction, f of y is equals to mass into y acceleration, f of z is equals to mass into z acceleration. Now, so these are the 3 resultant forces acting on 3 mutually perpendicular reference directions as x-axis, y-axis, and z-axis. So the forces x, y, and z are the components of the resultant force in the x direction, y direction, and z direction. And ax, ay, and az are the components of the total acceleration. So whenever you are considering the acceleration, the total acceleration For the three axes, we are considering ax, comma, ay, comma, az with respect to x, y, z directions respectively. Next, the forces acting on a fluid in motion. So what are the various forces acting on the motion? Next concept is, what are the various forces acting on the fluid motion? Fluid in motion. The various forces that influence the motion of the fluid. The various forces that influence the motion of the fluid are due to gravity, due to pressure, due to viscosity, due to turbulence, and due to compressibility. The various forces that influence the motion are the pressure, gravity, viscosity, turbulence, and compressibility. We'll discuss each one of them in detail. The gravity force Fg, the gravity force Fg is due to the weight of the fluid. The gravity force Fg is due to the weight of the fluid and is equal to mg. Okay, due to the weight mg. The gravity force per unit volume is equal to the gravity g, 9.81. Next, the pressure force Fp. So you are calling this as the pressure force Fp is exerted on the fluid mass if there exists a pressure gradient between the 2 points in the direction of the flow. So when the direction of the flow is in one direction in a pipe, the force exerted on the fluid mass exists a pressure gradient between the 2 points. The viscous force Fv. The viscous force is Fv. The viscous force Fv is due to the viscosity of the fluid. The viscous force Fv is due to the viscosity of the fluid flowing and thus exists in case of all real fluids. So what it is saying, the viscous nature of the fluid is the thing where it is in the real fluids only. It exists in the case of real fluids. Fv is nothing but the viscous force. Next, the turbulent flow Ft. The turbulent flow Ft is due to the turbulence of the fluid flow. So when this flow occurs, when there is any turbulence, in the fluid flow. The last one is a compressibility force, Fc. The compressibility force is due to the elastic property of the fluid. And it is the important only for compressible fluids. So when this type of force is acting on the fluid, whenever we are having the compressibility type of fluids. So classifications, we are having compressible fluids and non-compressible or incompressible fluids. So this compressibility factor is apply when the fluids are incompressible in nature due to elastic property of the fluid. Then we are using a compressibility force Fv. Now we'll see. In the certain mass of the fluid flow in a motion is influenced by all the above cases, then according to the Newton's second law of motion, what it is saying, the resultant force is equals to force into mass into acceleration, right? Resultant force F is equals to mass into acceleration. So we resultant any total force, what we can say, the net force Fx is equals to m into ax, that is equal to gravitational force in x direction, pressure force in x direction, viscous force in x direction, plus turbulent force in x direction, plus compressibility force in x direction. If the net force due to the compressibility Fc is negligible, the name rastam manamu, the net force compressible, whenever there is incompressibility force, we are ignoring the Fc, then we are writing Fc is equals to Fgx plus Fpx plus Fvx plus Ftx, and the equation is nothing but Reynolds equation of the motion. So what we are naming them as? We are naming them as a Reynolds equation of motion. Fx is equals to Fg of x plus Fp of x plus Fp of x plus Ft of x is a Reynolds equation of motion. Next, for the flow where Ft is negligible, the resultant equations of motions are known as Navier-Stokes equation. So if Ft is negligible, that is a turbulent force, we are calling them as Navier-Stokes equation. If the flow is assumed to be ideal, viscous force Fv is 0, and the equation of the motion is known as Euler's equation of motion. So whenever the fluid is in ideal condition, whereby the viscous force is like this, keeping it as a zero, thereby Fx is equals to Fgx plus Ftx, we are calling this as Euler's equation of motion. Right? So these are the various types of forces acting on the fluid which is in a motion. Hope you understood. Only 2 persons are present in this class. Very less number. Morning classes jarigaya meeku Raviteja and Snehalata. Hello. Just open your mic. Unlock your mic. Morning classes jarigaya. Yes. How many classes? Any classes jarigaya? How many classes? 1 class. Okay, 1 class jarigindi. Right. Yes, sir. So this is the second class ante. Max and fluid mechanics, right? CVSM is only the subject madam class or no madam class. Okay. So attendance today very poor. Okay. నాకేమవుతుంది నాకేమీ కాదు నేర్చుకోవాల్సిన సబ్జెక్ట్ మీరు. Anyways, I don't want to disturb the class. సరే మీ ఇద్దరు వినండి. Next one. In this fluid dynamics, we are having Euler's equation of motion. So this Euler's equation, just we have small changes in the Euler's equation. So manam mundu we got some equations, classification of continuity equation. So in the fluid kinematics, we discussed about the continuity equation. Now here we discuss about the Euler's equation and Bernoulli's equation also. Based on the Euler's equation and Bernoulli's equation, we are having some problems on that, and also the forces acting in the pipe bending, we are also having some of the problems. By maximum 3 or 4 classes, unit 2 also will get completed. Now we'll see in detail Euler's equation of motion. This is the equation of motion in which the forces due to gravity and pressure are taken into consideration. So ఇక్కడ Euler's equation అనుకున్నాం కదా, ఇక్కడ ఏం చెప్పాము, viscous force Fv is 0, మనకి ఇక్కడ Ft is 0. ఇక్కడ ఏం జరిగినప్పుడు Fv and Ft, సో Ft పోయింది, Fv పోయింది. సో అప్పుడు ఏముంది మనకి గ్రావిటీ అండ్ ప్రెషర్. సో ఇప్పుడు అదే కదా, due to the gravity and pressure are taken into consideration, this is derived by considering the motion of the fluid element along the streamline. Now consider a streamline in which the flow is taken in S direction as shown in the figure. So in this figure, if you see this one is a path, so this is a pipe where flow. Okay, so this is passing in this direction. So S direction ila oka bend agi itla veltundi, the direction. Along this direction, this particle is moving. Okay, now S direction. Consider a cylindrical element of cross section dA and length ds. Now see, the cross section is dA. And the length of this cylindrical section is ds, and this cross section is dA, and the cross section is a dA. Next, dA and the length ds. Okay. The force acting on the cylindrical element or the forces acting on the cylindrical element are, first one, pressure force PdA, cross section in the direction of flow. See here, PdA, the pressure force PdA along the cross section. Pressure into cross section. Next, second one is the pressure force dA opposite to the direction of flow. That is P of dou P by dou A into ds. Opposite to the direction of flow. Opposite direction ఏం జరిగింది? So దీనికి opposite direction ఏంటి? This one. So arrow ఇక్కడ ఇలా చూపించాడు, చూసారా ఇక్కడ arrow? The arrow is here. Here the arrow is like this. So the opposite to the direction, that is P plus rho dP by dou S into dou S. That is the opposite direction. Now the weight of the element rho GdA into ds. What is the weight of the element here? The weight of the element is rho jd as. So the weight of the element centering తీసుకుంటాం కాబట్టి the rho, the weight is rho into g into d into area into length ds. Next, let theta is angle between the direction of flow and the line of action of the weight of the element. The resultant force of the fluid element in the direction of s must be equal to the mass of the fluid element into acceleration in the direction s. Now, therefore, according to this mass into acceleration concept, therefore PdA, this direction, one direction, minus this one, PdA minus P plus dou P by dou S into dou S dA minus, what is this one? The weight of the cylindrical path, rho G dA ds cos theta, because we are having the cos theta, Now, this is a theta is angle, we are making a triangle. This one is a ds, this one is a ds, this one is a dz, this one is a theta. Then according to the cos theta, we are having adjacent by hypotenuse, that is equals to rho gd a into length of the cylindrical part into cos theta. Now, after getting simplification, rho into d into a ds into a, yes, keep it as 1 or 2, right? Next, where as is the acceleration in the direction of s. So if this is the direction of s, so then acceleration we are getting as a into s is the direction of the acceleration. Now as is equals to dou v by dou t, where t is a function of s and t. Now differentiating dou v by dou s is equals to dou s by dou t plus dv by dou t, that is equal to v dv by dou s plus dou v by dt, v dv by dou s plus dv by dt, since ds by dt is equals to v. So ఇక్కడ as is equals to dv by dt అన్నప్పుడు, where v is a function of s and t and as is the acceleration in the direction s, thereby dou v by dou s is equals to dou v by dou s into ds by dt is equals to v. So v ఇక్కడ substitute చేస్తే v into dou v by dou s plus dou v by dou t. If the flow is steady flow, dou v by dou t is equal to 0. If the flow is steady, it is 0. Therefore as is equals to v dv v dou v by dou s, right? So ఇక్కడ మనకి 0 అయిపోతుంది, స్టడీ ఫ్లో అనేది 0 అయిపోతే as is equals to v into dou v by dou s, అదే ఇక్కడ మనం రాసాం. Now substituting the value of as in the equation 6.2 and simplify in the equation, we get as ఉంది కదా into as, there is the acceleration. Now substitute here, we are getting as is equals to as, ఇక్కడ substitute చేస్తే, now what is this value here? Minus dou p by dou s ds into da minus rho g da ds cos theta, that is equals to pd rho da ds into dou v by dou s. Now see here, dou v by dou s dividing by rho ds by da, right? We are getting minus dou p by pds minus g cos theta, that is equals to v dou v by dou s. That implies dou p by rho ds plus g cos theta plus v dou v by dou s is equal to 0, but we have cos theta is equals to, ఇక్కడ మనకి cos theta ఏం జరిగింది, cos theta is equals to dz by ds, dz by ds. Now substituting this here, 1 by p, 1 by rho dou p by dou s plus g as it is cos theta plus dz by ds plus v dv by ds is equal to 0, or dp by rho plus d dz plus v dv is equal to 0. So ds is just this is the value we are getting. That implies dp by rho plus g dz plus v dv is equal to 0. The equation 6.3 is known as Euler's equation of motion. So the equation 6.3 is a Euler's equation of motion. So like this we have to derive the Euler's equation of motion, right? Now taking this one as a thing, the Bernoulli's equation from Euler's equation. How to get the Bernoulli's equation via Euler's equation, we'll see in this section, right? Now the Bernoulli's equation is obtained by integrating the Euler's equation of motion 6.3. So if you see here, దీన్ని మనము integrate చేస్తే, this equation మనం integrate చేస్తే, see here, after integrating dp by rho plus integral of g dz plus integral of v dv is equal to constant. If the flow is incompressible, this is kept as constant. If the flow is incompressible, this is kept as constant. Thereby p by rho plus g z plus v square by 2. Dou v ante v, so dou v integrate చేస్తే v వస్తుంది, v square by 2 is equals to constant. That implies p by rho g plus z plus v square by 2g is equal to constant. Therefore p plus rho g plus v square by 2g plus z is equal to constant. Equation this 6.4, this equation is a Bernoulli's equation where p by rho g is equal to pressure energy per unit weight and v square by 2g is equal to kinetic energy per unit weight, z is equals to potential energy per unit weight. So this one is a Bernoulli's equation. Then what are the assumptions of the Bernoulli's equation? What are the assumptions of Bernoulli's equation? The assumptions of first one, the fluid must be ideal. That is viscosity 0 lo undali. The fluid must be ideal. ఇందాక మనం ముందు చెప్పుకున్నట్టు viscosity is 0. Therefore assumptions to get the derivation is the fluid must be ideal. The second one, the fluid is steady, uniform. The fluid should be steady. The fluid should not be unsteady. It should be steadily flow. Next, the fluid is incompressible. The fluid must be incompressible. Compressible ఏందనుకోండి అక్కడ మన constant 0 రాదు, right? Therefore the fluid must be incompressible. Fourth one, the fluid is irrotational. The fluid should be rotational, right? The fluid must be rotational. At around, it should not be in a rotational movement. The fluid must be in a steady straight line motion. Then only these assumptions based upon the Bernoulli's equation will be valid, or else not valid. So these are the formulas for Bernoulli's equation from Euler's equation, and also this Euler's equation formula. Based upon these formulas, we will solve some of the problems now, right? So we are having good number of problems, 3 or 4 problems. Later we'll discuss Bernoulli's equation for real fluid and also the momentum equation, right? See the first one, the water is flowing through the pipe. The water is flowing through the pipe 5 centimeters diameter. So the pipe diameter is 5 centimeters. The water is flowing in the pipe under a pressure of 29.3 Newton per centimeter square and with a mean velocity of 2 meters per second. With a mean velocity of 2 meters per second. Find the total head or log or total energy. Find the total head or total energy per unit. Find the total head per total energy per unit weight of the water at the cross section, which is 5 meters above the datum line. Which is 5 meters above the datum line. Now, what is the given data? The diameter of the pipe is 5 centimeters as usual. Convert into meters. That is 0.5 meter. Then what is the pressure? The pressure is 29.43 Newton per centimeter. Convert into meter. 29.43 into 10 to the power of 4 Newton per meter. So diameter is given, pressure is given. Now the velocity of the pipe. The velocity of the flow is 2 meters per second, right? Then what is the datum line? Datum line Z is equals to 5 meters above. Therefore, what is the total head? The total head is equals to pressure head plus velocity head plus datum head. Now take this formula. The total head is equals to pressure head plus kinematic head plus datum head. Therefore, the pressure head is equals to pressure head pressure head is equals to P by rho g. The pressure head P is equals to P by rho g. Therefore, what is P here? 29.43 into 10 to the power of 4 divided by rho, you know that 1000, G is equals to 9.81. That is equal to 30 meter. Now, what is the kinetic head? The kinetic head is equals to V square. Kinetic head is equals to V square by 2G. Half mv square laga V square by 2G. That's equals to what is V here? V is equals to 2. So 2 into 2 by 2 into 9.81, 0.204 meter. Now what's the total head we are having? The pressure head plus kinematic head plus datum head. That is equals to P by rho G 30 meters plus 0.24 plus 5. That's the answer is 35.204. That is the total head of the water, right? Very simple and straightforward problem. So ఏమి ఇచ్చాడు ఇక్కడ? Given values data ఇచ్చాడు. Total head for value formula గుర్తుపెట్టుకోవాలి. The total head of the water is pressure head plus kinematic head plus datum line. Therefore, the pressure head కనుక్కోవాలంటే rho by 2g. The pressure head కనుక్కోవాలంటే rho by 2g. And the kinetic head కనుక్కోవాలంటే v square by 2g. Thereby, the total head is equals to 35.204 meter. Next, what is the next question? A pipe through which water is flowing is having diameter 20 centimeter and 10 centimeter at the cross section 1 and 2 respectively. The velocity of water at section 1 is given 4 meters per second. Find the velocity heads at the section 1 and 2 and also the rate of discharge Q కూడా కనుక్కోమన్నాడు, right? Now old formula, that is the momentum equation A1 V1 is equal to A2 V2 పెట్టుకుంటే, so ఎప్పుడు ఈ ఫిగర్స్ వేయాలి? Whenever you are getting the change in the diameter pipe like this, you can go for the momentum equation formula. What is the given data? The given data D1 is equal to 20 centimeters, that is equal to 0.2 meters. What is the D2? The D2 is 10 centimeters, convert into meter, that is 0.1 meter. Then the area at G1 is equals to A1 is equals to pi d square by 4, that is equals to 0.03. Then the V1 is equal to 10 centimeter. What is the velocity? The velocity is 4 meters per second. Next, the V2 is equals to 0.1 meter. And what is the velocity? 0.007 meter square. So this is the basic data what we will get from the question. Now we'll see the velocity. What to find? The velocity head at 1 and 2. So the velocity head at 1 and 2, velocity head is equals to V square by 2G. Okay, V1 square. 1 only కాబట్టి we are taking section 1 so V1 square by 2G, that's equals to what is the velocity? V into V, 4 into 4 divided by 2 into 9.81, that is equals to 0.815 meter. Good. Next, so if you see the velocity of the head at section 2, the same formula, V square by 2G. To find V2, so we don't know the value of V2. So in order to find V2, we have to go to the continuity equation. A1 V1 is equals to A2 V2. Now what is A1? We know A1, right? We know A2. We know V1. Now V2 is equals to A1 V1 by A2. That is equals to 16 meters per second. Now we got a V2. Apply this here. At section 2, we are getting 16 to 16 by 2.2 into 9.81, that is equal to 83.047 meters. The velocity at the section 2 is 83 meters. Now what is the rate of discharge? Q. We have to find a Q, or if we don't know the Q, input velocities. So directly you can go with A1 V1 or A2 V2. So what is A1 V1? A1 V1 0.0314 into 4 is equals to 0.1256. Okay, that is equals to 125 liters per second, 125.6 liter per second. There is a rate of discharge. So ఎంత rate of discharge జరిగింది ఈ మధ్యలో, ఎంత rate of discharge జరిగిందంటే ఇన్ని లీటర్స్ ఆఫ్ వాటర్ డిశ్చార్జ్ అనేది జరిగింది. దట్ ఇస్ ఆన్సర్ యూ హావ్ టు షో. అర్థమైందా ప్రాబ్లం ఇంతవరకు? Hope you understood this small simple problems. So ఈ fluid dynamics లో 90% will get a big problem. లేదంటే how to derive the Bernoulli's equation అని ఒక క్వశ్చన్ వస్తుంది, రైట్? నెక్స్ట్ థర్డ్ వన్. So keep in mind the formula pressure energy కి వచ్చేసి P by rho g అని రావాలి. ఓకే, ద ప్రెషర్ ఎనర్జీ కనుక్కోవాలంటే P by rho g. వెలాసిటీ కైనెమాటిక్ ఎనర్జీ వెలాసిటీ హెడ్ కనుక్కోవాలంటే V square by 2g. డేటమ్ ఎనర్జీ is symbolized as Z. Thus mathematically the Bernoulli's theorem can be written as pressure head plus velocity head or kinematic head plus datum line is equals to constant. P by rho g plus V square by 2g plus Z is equals to constant, right? So what the statement of Bernoulli's theorem is saying? It is saying that in a steady ideal flow of an incompressible fluid, take it as incompressible fluid, steady flow undali, ideal ga undali, incompressible fluid undali. The total energy at a point of on a fluid is constant. Ante kada? So the total energy at any point in the container should be constant. The total energy consists of what energy? Pressure energy, velocity, kinetic energy or velocity energy, and potential energy, right? Velocity, kinetic energy and potential energy or datum energy. Potential energy or datum energy, pressure energy and kinetic energy. These energies per unit weight of the fluid or even matter. So this is a statement of Bernoulli's theorem. So Bernoulli's theorem is saying that the fluid must be steady, first case. The fluid must be ideal, second case. The fluid must be incompressible. Then the total energy is given by the total energy of the fluid should be constant. Then what is the total energy? Pressure energy, kinetic energy, and potential energy or datum energy. Understand? Right. Now we'll see the next problem. Yes. The water is flowing through a pipe. So the water is flowing through a pipe having 20 centimeters and 10 centimeters diameter at cross section 1 and 2 respectively. The rate of flow through the pipe is 35 liters per second. The rate of flow through the pipe is 35 liters per second. 35 liters per second. The section 1 is 6 meters above the datum line. So this datum line anukunte kinda nunchi second section cross section datum line vachesi 6 meters. The section 2 datum line vachesi 4 meters. So if the figure is not given, by seeing the question we have to assume and we have to draw the figure. If the pressure is at section 1 is 39 Newton per centimeter, find the intensity of the pressure at 2. So find the pressure at 2 అని సింపుల్ గా చెప్తున్నాడు. సో మీకు ఆన్సర్ రాకపోతే ఫార్ములాస్ రాకపోయినా, if you don't know the concept, just read this question twice or thrice in the exam. Just draw the figure and show like this and write the given data. Basically enough. ఇది మీరు మినిమం రాసిన, ఫర్ ఎగ్జాంపుల్ ఇది 8 మార్క్స్ క్వశ్చన్, minimum you will get 3 or 4 marks. Don't neglect any type of question when you come across in the questions in the exam. Okay na? Now write the given data at section 1 దగ్గర రాసుకోండి, given data at section 2 దగ్గర రాసుకోండి. And what is the given data at section 1? Section 1, what is the diameter d1? d1 is equals to 20 centimeters, convert into meters, 0.2 meters. Then diameter ఉంది కాబట్టి ఆటోమేటిక్గా a1 కనుక్కోండి. a1 is equals to 0.314 meter square. Then what is the p1? Pressure is 39.24 into 10 to the power of 4 Newton per meter square. And the work you got from the data. What is the datum line? The datum line is Z1 is equals to 6 meters and on. Now see at the section 2 from the figure, You can see the datum line is that 2 is 4 meters. What is the diameter? D2 is equals to 0.10. Then find the area, automatically you will get 0.007. What's the thing you have to find? The intensity of pressure at 2, that is P2. That is P2. Now using the rate of flow, what is the rate of flow given? The rate of flow, the pressure is at section. Okay, the rate of flow through pipe Q is equals to 35 liters per second and inch. The Q is 35 liters per second. Therefore, 35 liters kabatti 35 by 1000 0.035 meter cube per second. Now Q is equals to A1 V1. So what is the V1? V1 is equals to Q by A1, that is equals to 0.035 divided by 0310. So you'll get V1. At the same concept, find V2. You are finding 4.4. Now apply the Bernoulli's equation at section 1 and 2. We are getting P1 by rho g plus V1 square by 2g plus Z1 is equals to rho 2 by rho g plus V2 square by 2 ఉన్నాయి కాబట్టి ఇక్కడ మనం 2 సార్లు మనం ఈక్వేట్ చేస్తున్నాం. There is only one. Apply to the constant C and you can do the is equal to 0 and you can do the problem also. Now substitute this value, substitute the values, substitute మనం V1 ఎందుకు తీసుకున్నాం ఇక్కడ? Why we are finding the, why we have found out the V1 here? Why? Because why you are finding V1 and V2? ఎందుకంటే మనకి Bernoulli's equation లో we are having the velocity energy. We are having the, this one is which one? Pressure energy, velocity, kinetic energy plus datum energy. So kinetic energy lo V1 ఉంది కాబట్టి from this discharge equation V1 ని తీసుకొని బయట పెట్టాం, V2 ని తీసుకొని బయట పెట్టాం. Now applying here V1 square plus V2 square, apply as it is 39.24 into 10 to the power of 4 by 1000 into 9.81 plus V1 square. V1 square is equal to 1.114 square by 2 into 9.81 plus the datum line 60. Apply P2 by 1000 9.81 44 into 0. So after getting simplification, so finally substituting this one, P2 is equals to this one minus this one, P2 is equals to 41 into 90 into this one. So finally 41 is 0.5 into 9810 meters square kabatti centimeters convert to the power of 4, that is equals to 40.27. That is the answer. Understood? So Ilana, you are having two problems and Bernoulli's equation for real field. Okay, we'll discuss in the other class. If you have any doubts, just unlock your mic and you can talk to me. Any doubts regarding these questions, regarding these problems? How the Bernoulli statement, what are the assumptions of Bernoulli statement, how to derive it? So how to derive, what are the assumptions? మీ ఇద్దరికి just message me or talk to me. Any doubts till here? Ravi Teja, Snehalata, doubts? No doubts. Okay, thank you. So the time is also running out. We'll stop here. Tomorrow మళ్ళీ ఒక కంటిన్యూ చేసి we are having Bernoulli's equation, detailed Bernoulli's equation, and also how to solve the problems in real fluids, as well as the momentum equation and the pipe bends problems. We will discuss those classes in tomorrow's class. Okay. So tomorrow we will start from 6.5 problem. It's very simple. Once this class is completed, I will upload this video in the YouTube. Later the link is forwarded to your group. Just open it, just practice it. So if you want the problems to get practice, I will send the PPT to your group also. Last class I have already sent the PPT. So if you find free time, just open your PPTs and just practice those problems. It will be very easy for you at the end of the exams, right? Okay, stop the class. So only two classes, only two students were present in this class. Very small. Okay, thank you for listening patiently.